All right, welcome to the lunchtime video. I'm going to keep going on this test here. Got a big day coming on Saturday, the 15th, I believe. Hopefully that's right. I've lately been kind of questioning myself a lot. I don't know, I've been, this morning, I kind of, the way I would describe it is I just kind of feel like I've been hit by a dump truck. So I think what's going on is I have my air filter off, so the allergies might be attacking me. But before I get started on this channel here, I would like to just make sure my video is uploaded that I did yesterday. I started a new series. It's going to be private for now. It's just reading some books. So I want to make sure I don't lose any videos for that. Oh yeah, so the next video is going to be Power of Paradigm. Yep, so okay, I got my video uploaded for that. So let's, now I will share my screen and let's continue the studying for the JNCIE-SP. Okay, so where we left off, we got stuck trying to get LDP signaling to come up. So this will be the third video in the series, and hopefully we'll get some answers. I've got a number of really good resources here. So let's read those. I think we'll start with the no more doubt, because I definitely have a lot of doubt, so to have no more doubt would be great. But before I get started with that, I'm going to pull up the lab and verify that I'm still having those issues. Oh yeah, I just do not feel good today. All right, so here's the configuration. You can see I'm trying to have a LDP. I'm trying to get a Mpls Lsp to work that I've got here, but unfortunately it's not working because it appears that this command implies that you're using RSVP. Okay, so yep, I clearly just don't understand. Oh, and before I move on, I'll do a show Mpls Lsp extensive. And now you can see what the problem is. It goes from originate call to bad source. But there is, as far as I understand, a way to, I mean, at some point it just straight up said RSVP not working. Because I mean, I don't even have it enabled, but let's try getting rid of the self-ping status. Okay, and we'll see if that changes anything. But really, I think the main problem is I just don't know enough about what's going on. So we can see we've got one at 0.4. Right now it's 0.6, so we don't have any new ones. But we should get a new one pretty quick. So we need a new originate call is what I'm looking for. One that says 1706. Nothing yet. Here we go. So there's one. It doesn't say 1706, but it says 1705. It is a new one though. Okay, so yeah, let's do some reading and hopefully throw aside any doubts with LDP. This article will focus on the Ldp protocol. Although this protocol is quite simple, I often had some doubts about some Ldp Junos commands and behaviors. This is the aim of this article: clarify basic Ldp stuffs. To speak about Ldp configuration on Junos, we will use this very simple and atypical topology. The IGP is OSPF, a single area, and Ldp is activated only on physical interfaces. So it's not activated on any of these loopbacks. As you can see, each router has two loopback interfaces. The basic configuration of each router is the following. Okay, so it looks pretty similar to what we've got. Different metric, different interface type, and they're making it passive. The first analysis that we're going to cover is the Ldp neighbor discovery and session establishment. On point-to-point links, I mean between two adjacent routers. An Ldp router discovers its neighbors by sending periodic multicast Ldp hello discovery messages based on Ldp Protocol 646. Once two routers see each other as neighbor, they start to establish a TCP session, port 646. This TCP session will be then used to exchange FEC /label mapping. By default on Junos, a router will only map a label for its primary loopback interface. It means that an Ldp router is by default egress PE only for its /32 primary LO address. Moreover, remember that by default, Ldp on Junos works in downstream unsolicited DU mode. Ordered label OL distribution. OL means that a router allocates a label to a specific FEC only if it receives a label mapping from the downstream nodes before. Therefore, only the egress PE, which own the FEC, will be the initiator of the first label mapping for its FEC. Then, subsequently, other routers may allocate and map a label to this FEC. A router sends a label mapping for a given FEC toward all its neighbors, even the downstream router that sent it via the FEC, aka there is no split horizon with Ldp. On Junos, the same label is allocated for a FEC for all interfaces. Other important thing, LDP forwarding exactly follows IGP forwarding, with this constraint: an exact match of the IP address of the FEC will be needed in the IGP routing table. In other words, to allocate a label for a /32, this specific /32 should be known in the IGP routing table. A more specific prefix will not be allowed. The LDP specification is quite cleared about this last point. An LSR receiving a label mapping message from a downstream LSR for a prefix should not use the label for forwarding unless its routing table contains an entry that exactly matches the FEC elements. Typically, in our topology, if P1 router receives a label mapping from PE1 LO address, it will accept it only if it knows the PE1 LO address, the exact /32, not a smaller prefix, in its routing table. In our case, it will accept the label mapping because LO0 addresses are well exchanged in our network via OSPF. Ldp Session Establishment. We consider now that all LDP/OSPF adjacencies are up and stables in our topology except one LDP relationship between PE1 and P1, which is still down. PE1 is a stub router, so in this case, it is not aware of any label mappings. Now let's set up the Ldp protocol on P1 interface and analyze on P1 the Ldp packets. Oh. PE1 sends Ldp hello message in multicast. Its packet includes some configurable parameters as the Ldp UDP neighbor dead timer, hold time by default 15 seconds, and the IPv4 transport address. Default is LO0 primary address, the one used to establish the Ldp TCP session. P1 sends back its parameters in UDP multicast as well. And finally, both routers consider that they are neighbors. Ldp discovery mechanism is a simple two-way handshake. Note, to override those default parameters, you can use the following commands. PE1 and P1 establish between them a TCP session and start to exchange the Ldp session parameters. So this I haven't had a problem with. The Ldp neighbors are totally fine. The problem I'm having is the Lsp over the Ldp neighbors. And unfortunately, it looks like there is no there's no guidance on that, unfortunately. Yeah, you know what? I think I'm going to skip this one because I don't see any guidance on an LSP. Let me search LSP. No, there's not even those three initials there. Okay, so let's take a look at this one and see if there's anything for LSP here. So we got lots of hits. Here we go. So this is an LDP signaled LSP. Oh, okay, yeah. So weirdly, RSVP LSPs are configured under protocols MPLS, not protocols and RSVP. So that is very weirdly, because that has actually completely thrown me off, because I thought that this configuration statement could apply to either LDP or RSVP signaled LSPs, but this is the statement you use to configure an RSVP LSP only. You use a different statement to hold on, I need to take a quick break here. All right, so I'm back. Right now I'm just looking through, because Juniper has some day one books that are pretty useful sometimes. So this is kind of where they really put their effort into documentation. You can see the ones we've been looking at so far have been pretty kind of filled with errors and stuff. So from what I understand, these are the ones that are really going to go through a more rigorous editing process. So I'm just trying to find one that is going to be good for MPLS. And I'm pretty sure it's this one, the Day One Ambassadors Cookbook. Okay, so here we go. This looks pretty good. There's 3 ways we can create an MPLS LSP. The easiest way is to turn on a protocol called LDP. The aptly named label distribution protocol. By simply turning it on, your routers will form neighbor relationships with each directly connected routers, just like an IGP does, and automatically starts advertising labels. In fact, when you use LDP, something interesting happens. Juniper routers only advertise labels for their loopback IP addresses. That means that if you turn on LDP in your example network, router 1 will learn a label to get to 3.3.3.3, but and this is dependent on the topology they're using. So LDP is quick to set up, and it gives us applications like Mpls VPNs, but it doesn't give us any control. The traffic only ever follows the best path learned from our IGP. Okay, so I think, and when they say set up a LSP, they're just basically saying exchange labels. Now, I would have thought that you would have some sort of equivalent to this statement, label switch path, for LDP, but it looks like it's just all under the hood, and that's the point of it. So you don't get any sort of verification or configuration command specifically meant for LDP. You can only have that for RSVP. So I think the only way you have to verify your Ldp RSVP, Ldp Lsp is to look in the inet.3 table. All right, so let's take a look at the inet.3 table. Okay, so we have LDP and we have pushing tags. So yeah, I think I'm gonna leave the video here and call this complete. Oops. Dang it. Oh, didn't want that to happen. Okay, well, light turned off, but that's okay. So if you just want the functionality of VPNs, use LDP. If you have an additional requirement for traffic engineering, use RSVP, and you'll need to, in any case, consider SR. What's SR? But anyways, if you use OSPF and RSVP, you've got to enable traffic engineering on OSPF. IG, if you use ISIS, you won't need to do that. I'm planning to use ISIS. Okay, yeah, but I think I'm gonna end it here. Unfortunately, it's just really not clear what an LSP looks like when it comes to LDP. If it's all under the hood, how would you verify an LSP? So I think the main reason you would do that is to just look at the inet3 routing table. And then you've got to learn how BGP resolves next hops. So an LSP is a path between two routers in a network that a packet will traverse to get to its destination. What makes this path different from regular IPv4, IPv6 path is the use of labels to do the next hop lookup. All the routers in the path pre-agree that if a packet is destined for a certain destination, the sending router will add a label to the packet to tell the receiving router what to do with it. No need to even look at the IPv4, IPv6 address. If you've never done MPLS before, you might think, hang on a second, why would we want this? Don't our routers already know how to forward a packet? Isn't that the whole point of a router? Well, yes, but when we create LSPs using MPLS, we get some very cool extra functionality beyond standard forwarding. For example, suddenly you can run layer 3 MPLS VPNs because you can forward by label instead of IP address, which gives you the ability to have the same private IP address space belong to multiple routers. Usually if you use the same IP address on two interfaces, you'd get an error. MPLS VPNs frees us from these shackles. You can perform traffic engineering where you create a path that goes a different way than what OSPF or ISIS tells you is the best path, which allows you to perhaps send your priority traffic the best way and send the best effort traffic a slightly longer way so that you can make the best use of your available bandwidth. You can even automatically calculate backup paths that kick in immediately if there's a problem in the network. There's 3 ways we can create an Mpls Lsp. The easy way is to turn on a protocol called Ldp, aptly named Label Distribution Protocol. By simply turning it on, your routers will form neighbor relationships with directly connected routers, just like an IGP does, and automatically start advertising labels. So this is where I'm confused. Automatically start advertising labels. Does that mean that it's going to form an LSP, or does that mean that the prior requirement to doing that is going to be resolved? It really never says that. It's very unclear what is the difference between, it's very, very unclear what an LSP is. In fact, okay, so an LSP is a path between 2 routers in a network that a packet will traverse to get to its destination. So do you have to configure this path? Is it automatically made? Like, can you verify this path? Like, it's very unclear about Ldp LSPs. I much prefer RSVP at this point because you're like, it's like, you know, it's all under the hood with Ldp, so I can't see it. So if I'm asked to do something about it, it's a lot more difficult for me to understand what I meant to do. Yeah, so this looks pretty good. So MPLS signals unidirectional LSPs with the help of distributing labels activated by a signaling protocol. What the heck? We just had a cleaning oh, I see. Okay, yeah, I can go to the dentist tomorrow at 7:30. Oh, and this is tomorrow. Oh, okay, yes, please. I'd rather do that. Oh, I keep missing appointments. It's so bad. I'm going to take another break. This is a really great resource, so I'll make sure that I include it in the description for this video. I'll include I'll include those 2 as well. I'll get rid of this one. All right, and then I'll take another short break, and I will be right back.